Hey everyone, welcome back, and today let's solve Leetcode problem 2337 titled Move Pieces to Obtain a String. So we're given two strings, start and target, both of length n. Now each string consists only of the characters string L, string R, and underscore, where the characters L and R represent pieces where a piece L can only move to the left if there's a blank space directly to its left, and similarly a right piece or piece string R can move only to the right if there's a blank space directly to the right of it, right, adjacent to the right of it. So the character underscore represents a blank space that can be occupied by any of the left or right string pieces. So we need to return true if it's possible to obtain the string target by moving the pieces of the string start any number of times. And otherwise, we have to return false if we can't do this. So to better understand how this problem actually works, let's go ahead and look at the example. So in example 1, we have start to be this input string and target to be this. And in this case, we can output true. Why is that? Well, we can use this L and keep going to the left of it, right? Because as we can see, we have an underscore over here, right? So we can basically just keep moving L until it reaches the index right here, the beginning. Keep moving it left, and we can do this, apply the same logic for these two R's. Keep moving them to the right because, as you can see, we only have these underscores here, so we're allowed to actually keep moving them to the right until the end of our string, and that would then effectively meet the target, right? And in the explanation, they kind of have the same solution here. We have to first move the first piece one step to the left, as this is an underscore. Then we'd have this, and then we have to move the last piece one step to the right, and then we'd have this, and then move the second piece 3 steps to the right, because we're not actually being conflicted or blocked by any other pieces, right? All the actual pieces that we're moving are not being blocked. They have space in the underscores to move to their left and right corresponding indices, and effectively we can actually reach this target string with any number of operations from our starting input string. So in example 2, we have start to be R underscore L underscore, and target to be underscore LR. Well, in this case, no matter what we do, we can never get L to be here and R to be after it, to the right of it. Okay, and the reason why is because the R string piece, as they say here, in the string start can move one step to the right. We can get to here, but we can't move anywhere else, right? Technically, sure, we could get L, or rather, we can even do that, right? Because these two are blocking each other. We can move R to be here, but then we can't move to the left with L because it's being blocked by R, and we can't move to the right with R because it's being blocked by L. They're both conflicting each other, right? We don't have space and underscores to keep going to reach the string, right? It is impossible to obtain the string target from these original indices of the R and L pieces, the right and left pieces, because they're being blocked by each other. We don't have any empty space to move their actual indices left and right to obtain this target string because they're being blocked. And finally, in example 3, we have our input string start to be the following and target to be this, and in this case, we still have to output false. Theoretically, we're not being blocked by anything here. R still has an underscore to the left of it, but the keyword is it's to the left. We can only move to the right, and so regardless of where R is right now, we can never ever move R to a lower index, or we can never move R to the left. Whatever it is, we can only go right. And in this case, we can't go right because it would be out of bounds, and we can't go left. We can't make it start, and so regardless of what we do, we can't really do anything, right? The piece in the string can only move to the right. It cannot go back to the left to the first index to match target, and so it is impossible to obtain this string target from our original input string target, or rather start. So with these examples out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so a very good kind of note that you should really realize in this problem is that we know that the string L can only move to the left, or rather the piece L can only move to the left. And so its index or position in our starting string has to be greater than or equal to its index in the target string. Otherwise, we would never be able to actually move it to its corresponding indice. And similarly, for any right pieces or right strings, they can only move to the right. And so its position in our starting input string has to be less than or equal to the actual position in the target, because we can only move to the right. Okay, similar logic. Okay. So the way we're going to actually kind of structure our solution, we're going to use a two-pointer technique, right? You've probably heard of this algorithm quite often. We're going to use this to actually compare the characters of the corresponding index, start, and target, while we actually skip over the underscores, right? Because we don't really care about underscores. They're simply just empty spaces that we can access later on, right? And that makes sure that we can actually consider the movement constraints of only moving left and right pieces to the right. So with that out of the way, let's go ahead and dive straight into the code here. So I'm actually going to have a quick base case here, kind of a quick check, and it's going to be kind of Pythonic, but I'll actually explain how it works. So if start, right, start again, is our input string, dot replace, now I'm using the replace method here, and my parameters are going to be an underscore, comma, an empty string, right? If it's not equal to target dot replace, and I'm going to have basically similar parameters. It's going to be, it's going to be an underscore and a string. If that's not the case, well, then I have to return false immediately, right? And what does this actually mean here? What are we really doing here? Well, we're basically checking if all the characters excluding the underscores in the start and strings, if they're actually the same, right? So what start.replace does, and these two parameters does, it basically just removes all of the underscores that actually are in our starting string, and it only leaves the L and R, right? We're replacing every single underscore with an empty string. Okay, we're only keeping the L and R pieces, or kind of indices, from our starting string, right? And target.replace would effectively do the same thing. It would only keep the L and R pieces and exclude all of the other underscores, right? And after we actually, or rather, if after actually removing all of the underscores from the start and replace strings, all these resulting strings, if they're not the same, that means that the two strings are going to have different characters, and that way it would be completely impossible to actually match start and to target, right? To actually obtain target, even if we do move the L and R characters, because they're simply just different. And so for that reason, we'd return false immediately. Just a quick base case. I don't think you really need this here. I feel like the test cases probably are guaranteed not to exclude this base case, but I just kept it just in case if it made any difference. So now let's actually initialize our pointer j. So j is equal to 0, and this is basically going to help us actually traverse our target string, right? It's simply going to track the current index or position in our target as we actually compare it to the characters, to the character with start. Now let's actually start enumerating through our input string start. So for I, and I'm actually going to enumerate over it. So for I and every character at that corresponding index in the enumerate of our input string start, right, where I is going to be the index of every single char or character in this for loop of our input string start, we want to first check, well, is our current character that we're skating through, is it an underscore, right? So if char or character, if it's equal to an underscore, we immediately want to continue. We don't want to have any computations. We don't want to do anything. We want to immediately just skip it and move to the next character in the next iteration. And that's because all of these underscores have to be ignored when we actually compare the positions between the start and the target strings, right? We don't actually need to check and compare them. They're simply just empty pieces or empty spaces that we can use to move our other left and right pieces. We don't actually care about them. They don't really impact the way we actually move our left and right pieces to help obtain the target string, right? So we can basically just skip over or continue on to the next iteration. Now we actually have to basically keep monitoring while the jth position is still an underscore. So while target at the pointer or index j that we initialize up here on line 5 to be 0, while that's actually equal to an underscore, so while it's actually equal to the string of an underscore, we want to move to the right, or basically increment j by 1 in our input string, right? So again, while basically the character at the jth index or position in our target string, while it's an underscore, we want to just increment j to effectively skip over it. right? We want to make sure that J actually points to a character or is at a character that is not an underscore, so we can actually compare it with the character at this index I for the current character in our starting input string. Okay, so we're going to do that with target to actually effectively compare it with the starting or with the character in the starting input string in this iteration at index I. So now that we've actually incremented our J by 1, now we have to actually have our checks to see if the characters are actually equal or mismatched. So it's going to be pretty lengthy. Just a quick one here. So the first kind of check we have to do is if the current char or character in this iteration, if it's not equal to target at J after we've actually incremented it so that it's not an underscore. Or the other case that we can have is if char is equal to the string L, basically if it actually is a left piece, I think they're all uppercase, yeah, if it's actually a string L and its index is less than the pointer J, right, that's our second check. Or our next check is going to be, well, is char a right string, so is it equal to the uppercase R? And I is greater than J, and if that's the case, if any one of these conditionals output true, we immediately have to return false in this function. But why actually is that? What does this really check for? Well, the first check that we have to actually do is this character mismatch, right? If the character from start doesn't actually match the character in this iteration at the jth position in target or at the jth index in target, we immediately have to return false. Now, the next two constraints are simply just the movement constraints or the movement kind of laws for our 2 pointers to see if they're breaking the rules of this problem or not. The first one is, well, if the current character is actually an L, if it's a left piece, but its index I in start is less than the index J, basically if L is moving to the right, then we have to return false because L should only move to the left. Its index cannot be less than J because we can only move left to the left. We can't move it to the right. And similarly, we're going to have a movement constraint or a kind of blockage for the right, right? If the current character is a right, but its index I is actually greater than J in the start index, right? In that case, that means we have to move right to the left, but that's breaking the problem's rules. We are not allowed to do that, and so R can only move to the right, and so we'd have to return false if any one of these conditionals can actually return true. If any one of them fail, we have to return false, and because we're already violating the movement constraints of the problem. And for every iteration in this for loop, we want to actually increment J by 1. And the reason why, because after we actually successfully compare the current character char and target and index J, we have to actually increment or move up J by 1 to the next character in our target for the next comparison, for the next conditional in the next iteration. And that makes sure that we're actually consistently progressing through both strings in sync. Okay, so effectively, if we don't return false in this for loop here, if we never have a mismatch or a movement problem here for any single character J, every single character char and J in our input string start and target, we can return true outside of this for loop here, because that means effectively that we have not found any issues in this for loop and at any iteration, right? That means we've actually successfully matched all of the non-underscore characters in start and target while actually keeping track or respecting the movement constraints of the problem, right? Where left only moves to the left, its lower index, and right only moves to the right, its higher index. And so we can return true if we never return false in this for loop here once it's actually done executing. So unless I made any syntax errors here, this should be accepted and this should be a valid solution. And as you can see, this is just about as efficient as you can get. So for a quick reiteration, a quick high-level rundown of how our algorithm actually works, effectively, we're simply just basically first thing is we're just actually comparing the start and the target input strings, and we're basically checking, well, can we actually transform start into target by only moving left, the left piece left, and only moving right piece right, okay? And we're going to do this by first checking if the characters excluding underscores are identical in this initial kind of base case or check here, right? And the next kind of part of this algorithm is we're going to actually use 2 pointers to actually traverse our 2 input strings start and target, where we simply just continue or skip over iterations over underscores, right? We don't care if we have an underscore. We want to just continue to when we actually have a left or right piece that we need to move, right? And we have to make sure that L and R, the string L and string R pieces in our start only can move left and right respectively, can only move to their corresponding character index in target without actually violating our problem's rules. And if we don't return true false for any character and target and index j, we can actually return true outside of this for loop here. So for the runtime complexity of this solution, this is going to be a big O of n solution, right? It's going to be a linear time solution where n is the length of our start string. And the reason why is because really it's just a one-pass solution. While we're iterating over each character in start exactly once in this for loop here, and the while loop inside of this main loop here, this while loop here, it's really just bounded by the length of our target, right? It only increments j when we actually see an underscore. And that basically means each index of target is actually visited at most once. And for the memory or space complexity here, this is going to be a big O of one solution. The reason why is because we're actually only using a fixed or constant amount of extra space. We're only using a few integer variables like j, and really that's it actually, if you really think about it. Yeah, it's really just j as our only integer variable. We're not actually using any auxiliary memory or any extra data structures, and we don't actually create any new basically any data structures that actually grow with our input size. And so this is going to be a constant time or big O of one space complexity. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye bye.